Got it. A very good afternoon to all. Yeah, myself Nikhil Gupta. I am assistant professor in mechanical engineering department in IIMT College of Engineering, Greater Noida. Today I am delivering a lecture, very interesting topic, and it's a very useful topic in any industry. The topic name is CPM and PERT. These are the outline of my lecture or presentation. The first point I will cover in this lecture, what is a project. Second one is the what is the CPM. Third one is the importance of CPM, and next one is the characteristics of the CPM. Then after the topic is terms used in CPM part, and then after I will discuss the problem discussion of the CPM, and after that we'll discuss what is the PERT and difference between CPM and PERT. Now, what is project? Basically, to understand the CPM, first we should know what is the project. A project can be defined as a set of number of activities that are performed in a certain sequence to determine the logically or technologically to complete within a specified time frame to meet the performance standard. In simple words, we can define a project is the combination of various activities which are interrelated, but the main important point is the time. The project is always defined by the time constraint. Time should be defined for a project. From many years, two approaches that have been proven to be useful for planning, scheduling, and controlling of any kind of project, even any industry, any software industry, any other. One is the critical path method, also known as CPM, and second one is the project evaluation and review technique. This is known as PERT. Now, what is critical path method? Basically, critical path method, CPM, is the mathematical based algorithm for scheduling a set of project activities. In other words, we can say the critical path method is the sequence of scheduled activities that determine the duration of any project. And a critical path is the also used to find the critical and non-critical activities of any kind of project. Basically, critical path is the longest path of any kind of network which have some starting event to end event and define that critical time to require the completion of a project. Next, by this example, we can explain what is the critical path method. A project consists 5 different paths in a network with duration. One is 10 weeks, second is the 13 week, third one is the 15 week, fourth one is the 20 weeks, fifth one is the 25 weeks respectively. In this overall project network, we can see here 10 weeks are the minimum time frame and 25 weeks are the maximum time frame. I have already discussed critical path is the longest path. We can see in this slide, critical path is the longest path. So in this project, 25 weeks is the longest duration. So we can say that 25 weeks is the longest path of this network or project. This is the diagram. We can understand a critical path. This is a project in which this is the starting point and this one is the end point. In this starting point, after that we can say this is the task 1 which take 3 days. This is the task 2, say D task, it take 2 days. Task E, third task, it take 4 days. Task F, it take 1 day. This is the route 1, or we can say this is the path 1. In this path, the total time duration is 10 weeks, 10 days. 3 plus 2 plus 4 plus 1 is equal to 10 days. Second path is task B, it take 4 days. Task C, it take 3 days, and then final event. In this duration, in this path duration, 4 plus 3 is equal to 7. We already discussed critical path is the longest path. In this project, in this network project, 3 plus 2 plus 4 plus 1 is equal to 10 days. it shows a critical path. We can say this is the critical path. Task A, task D, task E, task F, and then finish. And the length of this project is the 10 days. This is the another example. How to build a house in which two paths are showing. One is the install faucet, install fixture, install carpeting. Install faucet 2 days. This is the path 1. Install fixture take 4 days. Install carpeting take 3 days. The total duration of these activities are 9 days. In here we can say there 2 plus 4 plus 3 is equal to 9 days. Second route is dig foundation, it take 10 days. Build wall take 20 days. Build roof 10 days. Total is 40 days. This is the path 2. In this overall network, first path take 9 days and second path take 40 days. We already discussed critical path is the longest path. So we can say that 40 days is the critical path and the length of the path is 40 days. Another example, this is the starting and these are the tasks or activities also can say. In this path 1, we discuss path 1. Path 1 is the starting, activity A, activity D, activity F, activity I. We discussed in detail path 1. Activity A, it takes 25 days. Activity D, it takes 10 days. Activity F take 15 days. Activity I take 10 days. Means 25, 10, 15, 10 is equal to 60 days. This is the second route or second path. Starting point 1, 4, 6 and end. The duration of this activity or path 15 days for activity B, 5 days for activity E, 10 days for activity G, or here 5 days for activity J. The total duration of these activities are 35 days. 15 plus 5 plus 10 and plus 5 is equal to 35 days. The next path, this is the path 3rd here, starting the activity C and activity H, and the duration of these activity are 20 days of activity C, 20 days of activity H. Then total duration of these activity are 40 days. So 60 days in path 1, 35 days in path 2, 40 days in path 3. Then the maximum path duration is 60 days. So it is the critical path. And the length of this path is 60 days. Now how? These are some applications of the CPM. CPM PERT is very useful in research and development. It is also useful for equipment maintenance and hauling of a machine or any tools. It is also used for construction of project like building construction, bridge construction and dam construction also. It is also setting up new industries. It is also used for planning and launching of a new product. CPM PERT is also used to design of a plant, machine and system. It is also used to shifting the manufacturing location to another location, and it is also used to control of production of a large scale. These are some importance of the project. Network of critical path method. It analyzes and break down the project in terms of specific activities or event. It determines the independence and sequence of specific activities and prepare a network. CPM PERT is also assigned the estimation time, cost, or both to all the activities of a network. Now, before starting how to design CPM, we should aware the important terminology of the CPM. First, we should understand what is the activity. Basically, an activity is an identifiable job that has some beginning and end. Example, construction of walls, construction of roofing etc. Construction of roofing, and in other words we can say construction, reading of book, production of any plant is also any activity. To understand in network, This is the sign is how to define the activity. And the second one is the event. An event, also called the node, is the beginning or end of an activity. An event does not consume any time, manpower, or material resources, and it is represented by a specific point of a circle. We can say an activity has two events. One is the starting event, second one is the end event. Here, activity consume the time, but event does not consume any time. Next one is the critical path. Critical path is the longest path which connect the starting and end event. In this network, we can see here, critical path, it is the longest path connecting the starting and end event. Next one is the earliest starting time. It is the time at which an event is accepted to be completed at the earliest, and it is denoted by the TE. Here, this is the activity A, this is the activity B. The time taken in activity is 10 minutes and time consuming in activity B is 12 minutes. This is the event 1, this is the event 2, this is the event 3. This is the starting event for this activity A, and this is the end event for the activity B. This second event is the starting event for B activity, and this is the end event. How to calculate earliest starting time? T is 0 for starting event, but for second event, T is equal to duration of activity plus starting event plus 10 plus 0 is equal to 10. For next activity, the earliest starting time T is equal to previous TE plus duration of the activity. Means we can say 10 plus duration of this activity, means B activity. 10 plus 12 is equal to 20B, 22. Now, latest finish time, it is the time by which an event should be completed so that the project completion will not be delayed, and denoted by TL. How to calculate TL? This is the network in which A activity, B activity, A activity consume 8 minutes, B activity take 15 minutes. Already we can discuss. One is the event of starting event of activity A. This is the end event of activity A, and this end event is the starting event for activity B, and this is the end event of activity B also. Here, the latest finish time is always starting from end event. Means here, for end event, always TL is equal to TE. TL is equal to TE, and TE is equal to, for this, 0 plus 8 plus 15 is equal to 23. So for this event, TL is equal to T is equal to 23. And next, for this event, TL is equal to 23 minus duration of this activity. Means 23 minus 15 is equal to 8. And this event, we can calculate 8 minus 8 is equal to 0. Means we can say here, earliest starting time is calculated from starting event, and latest finish time is calculated from end event. Next, slack time. Slack time is the difference between TL minus T. TL is equal to latest finish time, and T is equal to earliest starting time. See, slack is always 0 at critical path, because at critical path always TL is equal to TE. Next is critical event. The event with 0 slack time are known as critical event, because at critical event, TL always equal to TE. Same critical activity, the path which follow the 0 total float are known as critical activity. Now, what is total float? Here, total float is the maximum time by which the completion of an activity can be delayed without affecting the project completion time. Means total float is equal to TL minus TE minus duration of the activity. This is the simple network in which A activity, B activity, A activity take 10 minutes, B activity take 12 minutes. For this event, t is equal to 0. For this event, next event means second point event is equal to 10. For this, t is equal to 22. Similar, for this end event, TL is equal to 22. For this event, TL is equal to 10, and starting event t is equal to 0. So total float is equal to TL minus TE minus duration of the activity. How? Then total float for B activity means for this activity, TL is equal to total float is equal to TL of the event 3 means for this event means 22 minus TE of the event 2 means previous event for this means 22 minus 10 here minus duration of activity B. If we calculate the total float of the activity B, so duration of the activity also taken 12 minutes. Then 22 minus 10 minus 12 is equal to 0. So total float is equal to 0 for the B activity. So total float is equal to TL minus TE minus duration of an activity. Next, preceding activity. There are some important activities in critical path method. One is a preceding activity. For any kind of activity, for any given activity, the activity that occur immediately before is known as preceding activity. This is the activity A, and this one is the activity B. So activity A is the preceding activity for activity B, always. Before previous activity is the preceding activity. Succeeding activity, it is just opposite. For a given activity, the activity that follow immediately after is known as succeeding activity. Means we can say for activity B, for this project, for this network, activity is B is the succeeding activity for activity A. Means just after activity is known as succeeding activity, just previous activity is known as preceding activity. Now, next one is the concurrent activity. The activity that can be carried out concurrently are called as concurrent activity. Here, example, digging of a well and excavation of foundation are concurrent activity. For this, this is the activity A, and this one is the activity C, and this one is the B activity. Means here activity C and activity B both are the concurrent because they are working as a concurrently. C activity is concurrent activity for B, and B activity is concurrent for C activity. Activity C and B are concurrent activities. Now, dummy activity. It is an imaginary activity in a network, and it does not consume any time because it is not real activity. The only use of dummy activity is to complete the network and denoted by dotted line. In this network, activity B is the dummy activity. Now, how to calculate CPM? To understand CPM, we take an example of heat exchanger. A heat exchanger consists following task periodically on the heat exchanger in refinery. And in this, we calculate, draw the network diagram of an activity of project, identify the critical path, and last one is the length of the project. These are the tasks: task A, task B, task C, task D, so on, task J. For this task, these are some predecessor activities. And for this task, these are the time. Task A is take 14 days. Task B take 22 days. Task C take 10 days. D take 16 days. E take 12 days, so on. And last one, J take 16 days. Now, how to draw the network diagram? First, task A take the 14 activity which does not have any predecessor. In this, like this, we draw the activity A. In it take 14 days. Activity A take one is the starting event 1, and this is the second event. Next, this is the activity B, which is the successor of the activity A. Here, activity B. This is activity B, which is the immediate predecessor of A and successor of A. it take 22 days. Here, next activity, activity C is the immediate successor of B, or C is the successor and B is the predecessor. Next, activity G is the next activity. It take 6 days and it is the successor of the activity C. One thing I want to know, I want to explain here, activity B, activity C, activity D. Sorry, activity C, activity D, activity E. In all activity, B, it's a predecessor of the both three activities, all three activities, C, D, and E. Like this. Means B is the predecessor of C. Next, D is also the predecessor of B, and E is also the predecessor B. Means activity C, activity D, activity E. All three activities are the concurrent to each other, but the predecessor of these all activities are B, and the successor are C, D, and E. The C is the also predecessor of activity G, as given in question, and activity F. Means we can say G and F both are concurrent to each other and are the successor of activity C. The H is the activity which is the successor of activity F, and F is the activity of predecessor of H. D1 is the dummy activity, because in this example here, G is the, H is the successor, H is the task, and F and G are the predecessor, but time is 8. Means F take 8 minutes, but G has 0 time. So Z is the dummy activity. Similar, here G is the dummy activity. Next, I is the successor of activity H, activity D, and activity E. Here I is the successor of activity H, D, and E. Here I is the successor of activity D, E, H. In other words, we can say D, E, H is the predecessor of activity I and take 24 days. Here means H is the predecessor of activity I, D is the predecessor of activity I, and E is the predecessor of activity I. But E is here, so to connect E to I, we should use a dummy activity T2. It also takes 0 time because dummy activity does not consume any time. Next, end event J. J is the successor of activity I. It takes 16 days. Here, J is the activity or task which have the predecessor of I and takes 16 days. Here, I is the predecessor and J is the successor. This is the overall network of the project. In this network, following path take from starting to end event. One path is path 1, path 2, path 3, path 4. In this project, in this network, 4 paths are starting to end event. One path is follow one event 1, event 2, event 3, event 4, event 5, event 6, event 8, event 9, event 10. In this all this path, time consuming 14 days, 22, 10 days, 6 days, 0, 8, 24, 16 is equal to 100 days. And second path is event 1, 2, 3, 4, 6, 8, 9, 10. This path take 14, 22, 10, 10, 8, 24, 16 is equal to 104 days. Path third, 1, event 1, 2, 3, 8, 9, and 10. It take 14, 22, 16, 24 plus 16 is equal to 92 days. The last path is 1, 2, 3, 7, 8, 9, 10. 1, 2, sorry, 1, 2, 3, 7, 8, 9, 10. It take 18 days, 88 days. So path 1 take 100 days, path 2 104 days, path 3 92 days, path 4 88 days. The total maximum days is 104. So path number 2 means 1, 2, 3, 4, 6, 8, 9, 10 has maximum duration. Hence, this is the critical path. And the critical length of this project is 100 days. Here, 1, 2, 3, 4, 6, 8, 9, and 10. This is the critical path of this project. Next is PERT, Program Evaluation and Review Technique. It is the method which is used to examine tasks in a scheduled and determine the critical path. Method variation. It analyzes the time required to complete each task and its associated dependencies to determine the minimum time to complete the project. PERT is depend upon three type of time: optimistic time, pessimistic time, most likely time, to calculate the expected time. First is the optimistic time. It is the shortest possible time in which an activity can be completed under the ideal condition. Next one is the pessimistic time. It is the maximum possible time in which an activity should be complete. Next one is the most likely time. It lie between optimistic and pessimistic time. Now, how to calculate expected time? Expected time is calculated optimistic time plus 4tm most likely time plus pessimistic time divided by 6. T is equal to TO plus 4tm plus TP divided by 6. Characteristics of the PERT. Basically, it serves as a base for obtaining the important facts for implementing the decision making. PERT form the basis for all the planning activities. PERT help management in deciding the best possible resources utilization method. PERT take advantage by using time network analysis technique. PERT present the structure for reporting information. PERT also help the management to identify the essential element for the completion of the project within the time frame. These are some important difference of the PERT. How to differentiate PERT and CPM? PERT is a technique of project management which is used to manage uncertain activities of any project. CPM is the technique of a project management which is used to manage only certain activities. It is event-oriented technique. It is a technique which means that network is constructed on the basis of activities. PERT is the probability model, but CPM is the deterministic model. It majorly focus on time as meeting time target. It majorly focus on time. Cost trade-off to minimize cost is more important. It is appropriate for high precision time estimation. It is appropriate for reasonable time estimation. It has non-repeated in nature job. It has repetitive nature of job. And there is in PERT there is no change. In PERT there is no chance of crashing as there is no certainty of time. In CPM there may be crashing because of certain time boundation. In PERT it does not use any dummy activities. It uses dummy activities for representing sequence of the activities. It is suitable for project which required research and development. It is suitable for construction of the project. So now the topic is covered. and differentiate also cover in PERT and CPM.